Okay, so we are finding each logarithm. Do not use a calculator. So this is what they give us. And when we're finding the log, remember that that means that we're looking for the exponent. So each one of these has to have an equals x at the end. That's first. So I leave myself a lot of room here, but you get the gist. Then we're going to write this in exponential form. So this is 2 as the base, x is the exponent, equals 4 is the answer. So 2 to the what power is 4, x is 2. This one, we want 2 to the x equals 32. So 2 to the what power is 32? 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. So x has to be 5. Well, here's another one with 2 as the base. This is 2 as the base, x is the exponent, and the answer is 64. Well, that's one more power of 2 than 32, so x has to be 6. And then, of course, we have 2 to the power of x equals 2 to the 10th. So if we're looking for x, then our x answer has to be 10. X is 10. All right, so that was number 12. These get a little bit more complicated because, our answers are in different formats like fractions and decimals and radicals. So we want to be ready for that. That should say 14. I got a little funky there. But again, all of these are looking for a log, which means we're looking for the exponent in all of these. So we're looking to put these into exponent form. This is 5 to the x power equals 0.2. 0.2 written as a fraction is 2/10. And 2/10 reduces to 1/5. And 1/5 is 1/5 to the first. So to bring this up into the numerator, it's got to be a -1. This is very similar to number 9. An example on number 9. For B, we have log base 5 of 1/125th is x. So that means 5 to the x has to be 1/125. We're going to make a common base with this. And 125 is 5 to the third. But because it's in the denominator, that makes x have to be a -3. This one, 5 to the x, equals the cubed root of 5. The cubed root of 5, written as a fraction, power on top, root under the ground. So that's 1/3. That means x has to be 1/3. So remember, we're bringing back our exponent rules, our radical rules, decimals, negative exponents, all of that's into play now. This one is tricky. This one is 5 to the x power equals 1. So 5 to the what power equals 1 whole? Well, remember, anything to the 0 power equals 1 whole. So x is 0. All right, so that leaves number 14. All right, we've got one more example to do, and that's number 16. These are interesting as well, and that's why I picked them, because they're all very different. For 16a, again, we're looking for the log, so we're looking for x, the exponent. I also wanted a little bit more space, so I put d down here instead of over here, squished. This is 6 to the x power equals 36. Well, that's not hard. That's just 2. 6 squared is 36. This one says 36 to the x power equals 6. So we need common bases here. So 36 is really 6 squared with an x. This is 6 to the first. So we're actually taking our exponent rules with solving equations, and now we're solving this. So our bases are the same. We need to set 2x equal to 1 and then solve for that. Divide both sides by 2 to get x alone. So that's a 1/2 power. Okay, recap. These need a common base. This is 6 squared. 6 squared times x. That's 2x. This is 6 to the first. Set our exponents equal to each other. Solve for x. Letter C. This is 6 to the x power equals 6 radical 6. Now, I'm going to break this up and I'm going to say 6 times radical 6. That means 6 to the first times 6 to the 1/2. So this is 6, like when I combine these by multiplying with exponents, I add them. This is going to be 6 to the 1.5. And that makes x 1.5. Now you can write that as 1.5 as a mixed number. You can write it 1.5 or you can write it 3/2. But the answer to that comes from the fact that these are 6 to the first and 6 to the 1/2 power. And when you multiply, you keep the base and add the exponents. Boom. Last one. 6 to the x equals, this is the cubed root of 1/6. So this is 1/6 to the 1/3. Now the good news is that this is the same power of 6. So this is 1 to the 1/3 and 6 to the 1/3. So this is the cubed root of 1 is 1 and 1 to the first is 1. So this is really written as this. And so 1/3 being in the denominator means that you're going to have a negative exponent. So this is going to be x is equal to negative 1/3. Done. All right, so what you're going to do is go to the last slide and you're done for this lesson.